Hello students, let's continue chapter 6 of science, that is physical and chemical changes. Let's now consider the other kind of change, that is chemical change. A change in which chemical properties of the substance change and one or more new substances are formed is called a chemical change. A chemical change is also called a chemical reaction. Often these changes are irreversible. Now we will discuss activity 6.6 to show that burning of magnesium is a chemical change. We will take a small piece of thin strip of ribbon of magnesium. Students, you can see this is the magnesium ribbon. Clean the tip with sandpaper and bring the tip near a candle flame and burn it. You will notice that ribbon of magnesium will burn with brilliant white light. Students, you can see here ribbon burns with a brilliant white light. When it is completely burnt, it will leave behind a white powdery ash. Students, you can see when it is completely burnt, it leaves a white powdery ash. You can see in the picture. When magnesium burns, it reacts with oxygen to form magnesium oxide. The change can be represented by the following equation. Students, you can see equation in this picture. So you will observe that this ash is magnesium oxide, which is a new substance other than magnesium. Students, it is dangerous to look directly and for long time at the burning magnesium strip. So we conclude that burning of magnesium is a chemical change. Now we will understand that what happens if we dissolve magnesium oxide with water. First collect the ash, that is magnesium oxide, and mix it with a small amount of water. Stir the mixture well, then test the mixture with blue and red litmus papers. You will find that it turns red litmus blue. So, on dissolving the ash in water, it forms a new substance, that is magnesium hydroxide, and it turns red litmus blue. So, magnesium hydroxide is a base. So, magnesium oxide is a new substance formed on burning of magnesium, and magnesium hydroxide is another new substance formed by mixing magnesium oxide with water. So we can say that burning of magnesium ribbon is chemical change and dissolving magnesium oxide in water is also chemical change. Both are chemical changes. Now we will discuss activity 6.7 to show that change noticed on putting an iron blade in copper sulfate solution is a chemical change. Dissolve about a teaspoonful of copper sulfate, that is blue vitriol or Neela thota, in about half a cup of water in a glass, tumbler or a beaker. Add a few drops of dilute sulfuric acid to the solution. You should get a blue colored solution. Save a small sample of solution in a test tube or a small glass bottle. Drop a nail or a used shaving blade into the remaining solution. Students, you can see in the figure here blade is used. Observe the color of the solution. Compare it with the color of the sample solution saved separately. Do you see any change in the color of the solution? Take out the blade. Has it changed in any way? The changes that you notice are due to a reaction between copper sulfate and iron. The change of color of the solution from blue to green is due to the formation of iron sulfate, that is a new substance. The brown deposit on the blade is copper, another new substance. We can write the reaction as. So we conclude that change noticed on putting an blade in copper sulfate solution is a chemical change. Now we will discuss activity 6.8 to show that the change occurring on mixing vinegar and baking soda is a chemical change. Take about 1 teaspoon vinegar in a test tube. Add a pinch of baking soda to it. You would hear a hissing sound and see bubbles of a gas coming out. Pass this gas through freshly prepared lime water as shown in figure. When we will pass this gas through freshly prepared lime water, then carbon dioxide with lime water gives us calcium carbonate and water. When carbon dioxide is passed through lime water, calcium carbonate is formed, which makes lime water milky. The turning of lime water into milky is a standard test for CO2, that is carbon dioxide. So, vinegar and baking soda together produce carbon dioxide, and carbon dioxide gas turns lime water milky. Chemical reaction between vinegar and baking soda takes place and bubbles of carbon dioxide are coming out. And chemical reaction between carbon dioxide and lime water take place and calcium carbonate is formed. Calcium carbonate is a white substance insoluble in water which makes lime water milky. So we conclude that change occurring on mixing vinegar and baking soda is a chemical reaction. Now I will explain that how chemical changes are important in our lives. Chemical changes are important in our lives in following ways. Useful new materials such as plastic, artificial fibers, polythene, artificial rubber, detergents can be produced by chemical changes, and all new substances are formed as result of chemical changes. For example, digestion of food in our body, ripening of fruits, fermentation of grapes, etc. happen due to series of chemical changes. A medicine is the end product of a chain of chemical reaction, and new materials can be discovered by studying chemical changes. In a chemical reaction, new substances are produced. Moreover, the following changes are also seen. Heat or light may be given off or absorbed. Sound may be produced. A change in smell may take place or a new smell may be given off. A color change may take place. A gas may be formed. Let's look at some examples. You saw that burning of magnesium ribbon is a chemical change. Burning of coal, wood or leaves is also a chemical change. In fact, burning of any substance is a chemical change. Explosion of a firework is a chemical change. You know that such an explosion produces heat, light, sound and unpleasant gases that pollute the atmosphere. That is why you are advised not to play with fireworks. When food gets spoiled, it produces a foul smell. So, spoiling of food is a chemical change. And photosynthesis process in plants and digestion of food in our body are also chemical changes. Students, you must have noticed that a slice of an apple acquires a brown color if it is not consumed immediately. If you have not seen this change in color, cut a fresh slice of apple and keep it away for some time. You can repeat the same activity with a slice of potato or brinjal. The change of color in this case is due to the formation of new substances. Students, when slice of a cut apple is exposed to air for some time, it acquires a brown color due to the formation of new substances by the action of oxygen present in the air. Hence, the change in color of the cut apple slice is a chemical change. Students, now we will continue this chapter in next video. Up till then, thank you and goodbye.